What is the difference between supervised and unsupervised learning? Supervised learning uses labeled data to train models where the input-output relationship is explicitly provided. On the other hand, unsupervised learning works with unlabeled data, aiming to identify hidden patterns or groupings within the dataset. Some of the examples include clustering and dimensionality reduction. Can you explain the bias variance trade-off? The bias variance trade-off refers to the balance between the two sources of error. Bias is the error due to overly simplistic assumptions in the model, leading to underfitting and poor performance on both training and test data. Variance is the error due to excessive complexity in the model, causing it to overfit the training data and perform poorly on new unseen data. So the trade-off lies in finding the optimal model complexity that minimizes both types of errors. What is the confusion matrix? It's a table used to evaluate the performance of a classification model by comparing the predicted labels to the actual labels. Some of the components are true positive, true negative, false positive, and false negative. How do you handle missing data in dataset? It can be handled by many ways, like we can remove rows or columns with missing values. We can impute missing values using statistical methods like mean, median, mode, or predictive modeling. We can use algorithms that can handle missing data intrinsically. Can you explain what is cross-validation and why is it important? It's a technique for evaluating machine learning models by training multiple models on different subsets of the data and assessing their performance. It helps ensure that the model generalizes well to unseen data. The most common type is k-fold cross-validation, where the data set is divided into k subsets and the model is trained and tested k times, each time using a different subset as the test set. Alright, can you explain the concept of overfitting and underfitting in machine learning? There are few differences between the both concepts. Overfitting is a model that performs exceptionally well on training data but poorly on unseen data. It is too complex, capturing noise in the training data. It has low bias and high variance. Underfitting, on the other hand, performs poorly on both training as well as unseen data. It is too simple to capture the underlying pattern in the data. It has high bias and low variance. Some of the examples of overfitting are deep neural network trained on small data or polynomial regression with very high degree. And the example of underfitting concept are linear regression for non-linear data or decision tree with depth too shallow. What are precision and recall and how are they related to the F1 score? Well, precision is the ratio of correctly predicted positive observations to the total predictive positives. And recall is the ratio of correctly predicted positives to all actual positives. And F1 is the harmonic mean of precision and recall. So it balances the trade-off between precision and recall. Good. So what is regularization in machine learning? Well, regularization is a technique used to prevent overfitting by adding a penalty term to the loss function. This kind of penalty discourages the model from assigning excessively large weights to features by simplifying the model and improving its ability to generalize to unseen data. Some of the common types of regularization include L1 and L2. Can you explain the difference between bagging and boosting? Bagging, also known as bootstrap aggregating, is an ensemble technique that trains multiple models independently on different subsets of the data and combines their predictions by averaging or voting. The example being random forest. Boosting is an ensemble technique that trains models sequentially, where each model tries to correct the errors of the previous one. The predictions are combined using a weighted sum. The example being gradient boosting. So, what is the purpose of ROC curve and what does AUC represent? ROC, also known as Receiver Operating Characteristic Curve, is a graphical representation of a classifier's performance, plotting the true positive rate against the false positive rate at various threshold settings. And AUC, or area under the curve, represents the overall ability of the model to discriminate between positive and negative cases. AUC value of 1 indicates a perfect model and 0.5 indicates a model with no discriminatory power. What is the difference between a generative and a discriminative model? Well, generative models learn the joint probability distribution of the input features and the target labels, allowing them to generate new data points. On the other hand, discriminative models learn the conditional probability distribution of the target labels given the input features, focusing on the decision boundary between classes. Alright, explain the difference between parametric and non-parametric models. Parametric models have a fixed number of parameters and their complexity doesn't change with the amount of training data. Some of the examples like linear regression and logistic regression comes under parametric model. Non-parametric models have a flexible number of parameters which can grow with the amount of training data. The example include decision trees. Can you explain the curse of dimensionality and how it can be addressed? The curse of dimensionality refers to the challenges and difficulties that arise when working with high dimensional data, such as increased computational cost, risk of overfitting, and sparsity of data points. It can be addressed by dimensionality reduction techniques like PCA or TSNE and by feature selection methods. What is gradient descent and how does it work? Gradient descent is an optimization algorithm used to minimize the loss function of a model. It works by iteratively adjusting the model's parameters in the direction of the negative gradient of the loss function with respect to the parameters. The step size is determined by the learning rate. Variants include batch gradient descent, stochastic gradient descent, and mini batch gradient descent. Can you explain the difference between convolutional neural network and a recurrent neural network? CNNs are designed for processing grid-like data such as images. They use convolutional layers to automatically detect spatial hierarchies of features and are widely used in image recognition tasks. RNNs are designed for sequential data and can capture temporal dependencies. They use recurrent layers where the output from one step is fed as input to the next step. RNNs are widely used in tasks like time series prediction and NLP. Can you explain the concept of transfer learning in machine learning? Will transfer learning involves leveraging a pre-trained model on a large data set and fine-tuning it on a smaller task-specific data set. This can significantly reduce training time and improve performance, especially when the target task has limited data. And it's commonly used in deep learning apps like image classification and NLP. What is the role of activation functions in neural networks? Activation functions introduce non-linearity into the neural network. Common active functions include sigmoid, tanh, ReLU, leaky ReLU, etc. What is a hyperparameter and how is it different from a parameter? Parameters are internal to the model and are learned from the training data, such as weights in a neural network. Hyperparameters, on the other hand, are external and set before the training process, such as learning rate, number of hidden layers, and batch size. They control the training process and model architecture. Please explain the concept of feature engineering. Feature engineering is the process of using domain knowledge to create new features or modify existing ones to improve the performance of a machine learning model. It involves techniques like normalization, encoding categorical variables, creating interaction terms, and deriving new variables from existing ones. What are some common metrics used to evaluate regression models? Some of them are mean absolute error, mean squared error, root mean squared error, and R squared. So that's all about the interview questions related to machine learning. Thanks for watching, and please don't forget to like, share and subscribe to stay tuned with many more such vlogs.